It's good to be with you. Welcome to Class Outside. Today, we're going to learn how to load models from a URL in Unity. I will be demonstrating with Unity version 2022. We will also need these scripts available on GitHub. We will need the backend to provide the 3D models. A demo project for this is also available on GitHub. A code editor will be used to make changes to our project. I will be using Visual Studio Code. We'll also need Node Package Manager or NPM and Node.js installed to help set up and run our project. We will also need OpenSSL to support HTTPS on our local network. We'll need a 3D model in GLB format. I will be using this 3D model of a mushroom, available for free on fab.com. Specific versions used, other tutorials mentioned, and download links are all available in the video description below. I'll start by creating a new Unity project. This project should work similarly for any style, 2D, 3D, or XR. For simplicity, I will choose the universal 2D template. Once loaded, right-click in the hierarchy and create an empty game object. I will name the object SpawnManager. Select and move the game object so that it is within the camera's view. This is where the 3D model will be spawned. Then, let's add a button. When we interact with this button, it should trigger the process to load our model. Right-click the hierarchy, go to UI, and select Button. If a pop-up appears, you may press Import Text Mesh Pro Essentials. The button might appear strange at first. We can fix this by going to its parent canvas, which was loaded in along with it. In the inspector, change the render mode to Screen Space Camera, and then drag in the camera object. Now we can move the button around as we please. Let's download the code available on GitHub. Click the code button and download the file. Once downloaded, locate it and extract all. Let's create a new folder for these scripts in Unity's project panel. I'll name my folder loadglb demo, and then let's drag the scripts into this folder. If we look in the console, we will immediately see many errors. This is because the script uses a tool called gltfast, which is not in Unity by default. We can download this from Unity's Package Manager. From the top bar, select Window, and then Package Manager. Click the plus icon, and select Add Package by Name. Paste the package name, which should be provided in the video description, and click Add. Unity's fork of gltfast should now be available in your project, and the errors should go away. Let's briefly review the code for SpawnManager's script. I will open the script in VS Code. The SpawnGLB function passes the base URL to SpawnGLB async. It calls SpawnGLB async, which prepares a GLTF import task. In LoadGLB, this sets up some gltfast import settings. Then it builds a custom download provider. The two other scripts include this download provider and another certificate provider. These two custom scripts work to allow traffic with self-signed certificates. While this might be acceptable for testing on local networks, you may want to replace it with the default download provider when operating on public networks. Then, we load the GLB, and if it's successful, we call a method to instantiate it. This method creates a parent game object and places the loaded mesh inside of it as a child. Let's open VS Code to the backend project folder. This project listens for requests and supplies a GLB file when it's called. First, open a terminal window and run npm install. Then, change the directory to the keys folder and use OpenSSL to set up the key and certificates needed for HTTPS. If you have not yet downloaded OpenSSL, the link should be available in the description, as well as another video going over how to set up a website on a local network that works with HTTPS. I've pasted the OpenSSL command in the video description. You can click enter through each request or provide responses to the information it asks for. For local testing, I usually leave the fields blank. Let's change back to the root directory and start our backend with node server.js. Run that command and it should start. Now that our server is running, we need to get our local IP address and add it to our server manager script. In VS Code's terminal panel, we can click the arrow next to the plus button to open a new command prompt terminal. When open, run the following command, also available in the description. This command should output the IP address your backend is being hosted on. Let's add this to the base URL in the script. Now, we need to add the script to an object and prepare the button to call it. Back in Unity, click on SpawnManager and drag the SpawnManager script into the inspector of the object. Let's make sure the base URL seems correct. Then, let's drag the SpawnManager object from the hierarchy panel and place it in the object's spawn field. This is where the 3D model should spawn. Let's open the buttons game object, and in the inspector, scroll down to the button component, and under onClick, press the plus button. In the new field, drag the SpawnManager game object. This gives the button access to its components. Then in the dropdown, select SpawnManager, and choose the option to call the SpawnGLB method. Now when the button is pressed, the SpawnGLB method will be called. Let's download our 3D model to be displayed. Visit Fab at the link below in the description. Download the model in GLB format. Extract the downloaded folder and navigate to the included GLB file. Copy this and paste it in our backend's public models folder. If we look at the backend code, we will see the server.js file. Here we see that calling a URL at port 3001 with /models will call the methods in the model controller. In the model controller, we see that adding a /glb will call the getGLB method. GetGLB then calls model service and passes the file name listed above. This name must match the file we intend to spawn. If it does not, you may need to change it and restart the backend. Our Unity project now has gltfast installed, a button available to call our script, and our script will send a message to the backend requesting the GLB file. And the backend is running and ready to return our GLB file. Let's press play and test this out. After a moment, we should see the mushroom load. It is a bit small by default, so we can find it in the hierarchy, and then in the inspector, click this icon, and then increase the scale for all 3 values. If the model appears strange, like it is pink or missing color, there may be a shader issue. GLTfast and Unity rely on shaders to visually represent the material on the mesh. This means for us to see textures, we need to ensure Unity has the proper shaders. To start, we can drag and drop some example GLB files into our Unity project. Let's drag our mushroom in. Now, the shaders required to load that GLB should be recognized by the project. To make sure these shaders are loaded in our build, we need to go to Edit Project Settings, Graphics menu, and scroll down to the Shader Loading section. Click the Save to Asset button, and save this to the Assets folder. Then, increase the preloaded shader size by 1, and drag the newly created asset into the new preloaded shaders element. This tells Unity in the browser to load the shaders we expect our GLB files to use. If your model appears pink, or your browser console has logs about missing shaders, you most likely need to repeat this step, and add the model with the relevant shaders to your Unity project. Now that the shaders are added, I will delete the model from the project and run again. Look at that! Together, we have loaded a GLB file over the network in Unity. Please, let me know down in the comments what you thought of this video. Have a great day, and thank you for attending Class Outside.